Hello everybody. Welcome to the second section of the course Cognitive Modeling. This section will be focused on the studies of language acquisition and processing and the computational models that have been developed for helping to study language. So we are going to look at various aspects of language learning and language processing, and we are going to look at a bunch of case studies, meaning computational models that have been developed and proposed to tell us more about how humans might actually perform this task of learning a language. So in this introduction lecture, what I'm going to do is I'm going to go over the concepts that we introduced in the very first lecture when we were talking about cognitive modeling in general, and see how we can adapt them to the case of language. So the main questions that we discussed that a study of human cognition wants to answer now have to be adjusted to the domain of language. So in this domain, the main questions are still about representation of the linguistic knowledge. So we are now talking about a very specialized kind of knowledge, which is about language. And the questions can be divided into how this knowledge is organized in mind and brain. Do we have separate areas for, say, our grammatical knowledge and for our knowledge about the words or the phonology? Do we have separate representational frameworks for storing these, or they are all somehow related? And what is more, one of the main questions in this field is which part of this knowledge is innate, meaning we are actually born with it, and which part can be learned from the data that children and adults have access to. And the second group of main questions concern the acquisition of linguistic knowledge. So, excuse me, are different types of knowledge acquired in a specific order, or are every aspect of language is being developed simultaneously? And finally, what are the processes involved in language learning? Now, in the history of studying language, these questions have been organized and arranged in a different way slightly. So there has been a very old debate on language modularity, which is focused on whether we store the different knowledge of language, but about different aspects of language separately in mind, and whether they follow different representational frameworks and whether they're being learned through different mechanisms and in a different order. The question of what part of the knowledge is innate and what is learnable, and what are the processes involved in organizing and in acquiring them, has been famous as the central language learnability problem. And we will go back to these questions when we talk about the acquisition of syntax. But before even we get into detail, you might remember having heard these kinds of debates as one of the core pillars of cognitive science. So, as we said before, in the domain of language, again, we can use experimental investigation to learn things about how humans behave in certain situations. There are several experimental paradigms that have been specifically developed for studying language. For example, measuring reading times by projecting a sentence one word at a time on a screen and letting the participants pace themselves through it. And then by measuring how parts of the sentence are more difficult for learners to process than the others, we actually can somehow tap into the complexity of processing sentence structure that's behind the scene. Another methodology that you might be familiar with or might have heard about is tracking eye movements of the subjects who are looking at a sentence. So this time you are actually showing a whole sentence on the screen, and then you are tracking the movements of the eyes of the participants who are reading the sentence. So the eye movements have been shown not to follow a purely linear track, so it's not like they look at each sentence, each word in the same order that they appear in the sentence, but sometimes they switch back to earlier words, and that switching back has been suggested to indicate certain dependencies between words that follow the structure of the sentence. So this is another widely used experimental methodology for studying language. These two methodologies are more suitable for adults who can read, or at least, older children who can read, but don't tell us much about how children process language, and therefore there are certain methodologies that have been specifically developed for studying language development and language processing in children. One of them is preferential looking, where you show two parallel screens to the child describing two different kinds of actions, and then you play a sentence such as, look, Tim and Kim are blinking, and then try to detect which interpretation or which event on which screen the child looks at as a result of their understanding of what the sentence means, which in this case would be the intransitive, mutual movement, non-causal action that's happening on the left-hand side of the screen. And there are several more of these methodologies. Also similar to what we said in the introductory lecture, you can complement these kinds of experiments with computational simulation of the process, because this gives you certain advantages. It gives you full control over the data. It gives you the advantage of being able to observe the behavior as a result of changing aspects of the learning mechanism itself, and it allows you to test novel predictions about novel and understudied situations. And on top of all that, you have to make all your assumptions explicit in a computational model, which is a major advantage, because then there is no vagueness or doubt about why certain things happen. Now, I hope you remember the issue of cognitive plausibility. We discussed that if we are claiming that our computational model simulates a particular process in human brain, then the model has to follow certain criteria that applies to humans as well. So the model cannot, for example, assume that there is unlimited processing in memory, because humans face memory limitations and processing limitations. In the domain of language, there are a bunch of other plausibility criteria that models have to observe. For example, when we talk about using realistic input data, we cannot assume that children have access to consistent corrective feedback from their parents, because even though sometimes parents correct children's mistakes, it's not something that's always available to all children in all cultures. Therefore, we have to be realistic about the assumption of the availability of such input to the learner. Also, we cannot really rely on strategies that are very specific to a particular language. For example, if you assume that the word order of the language that you're hearing is fixed, and then develop a model based on that assumption, this model cannot really be easily generalized to cases where you have a free word order language, where the marking of various grammatical functions is done differently using another device, for example, morphological tools, rather than using a fixed word order. So these have to be taken into account. You cannot really build a model that only works for a subset of languages and then claim that this is how humans work. Also, when we talked about incrementality, we mentioned that the way human brain works, it has to rely on pieces of information. It has to learn from experience as it experiences them, and then update its knowledge about the domain based on that experience gradually. And in the case of language, this means two things. One is that when learning language, the learner has to process every instance of language use, whether it's a phrase or a single word or a sentence, as they receive them. They can't store them and wait for a large enough set of input before actually starting to process this information. When language processing or when language understanding happens, several studies have shown that humans build an incremental understanding of a sentence as it unfolds. So you don't wait until the sentence is finished before starting to understand what it means. And this has to be mimicked in the models of language processing as well. Now, let us also quickly look at the concept of evaluating a model. We before discussed this briefly in general for all cognitive models. In the case of language, again, our main challenge here is that even if we have a model that learns something about language, we cannot compare that knowledge directly with what humans know about language because we can't access that. What we have access to is how they use this knowledge, and therefore that's how we can evaluate our model, by comparing its performance to how humans perform in a similar situation. Now, how do humans use their knowledge of language? Typically either through processing and understanding the language input, or by producing language, or by speaking or writing. And these two are mainly our sources for comparison and for evaluating what the model does and how close it is to what humans do. So for comprehension, for language understanding, we have to rely on experimental studies of understanding. We have to look at what these experiments reveal in terms of biases and preferences, what kind of information children are sensitive to, and whether our model follows the same pattern. In the case of, for example, in the experiment that I already showed you, if we are modeling this process of understanding a sentence, then our model should also prefer a non-causal interpretation for an intransitive sentence as opposed to a causal interpretation when an agent is doing something to a subject, to a theme of the event. So that's what we can do. We can try to simulate experiments such as these and then show that our model shows similar preferences to children who are learning a language. In the case of language production, we have actually a lot of data available to us now which shows how children produce sentences. And this data is very valuable to researchers. It shows developmental patterns, how the utterances become more complicated as the children age, how the structure of the sentence evolves, and what kind of errors children make, which, as I mentioned before, is equally important. We want a model of human language to also explain to us why such errors are being made. We have several resources for child-adult interaction data that are publicly and freely available. The most famous of them is the database called Childess. This is a database of transcriptions and also occasionally video recordings or audio recordings of sessions where the same child interacts with their caregivers over time. And so you can see how the knowledge of the linguistic knowledge of individual children evolves over time. There are also annotated videos collected, for example, in resources such as TalkBank that can be used. And other resources which I have listed here, and these are hyperlinks, so you can actually click on them and go and explore. And I have put more information about the Childess database specifically because this is something that you have to use for your first assignment. Now, when we are talking about language is a very complicated system, and typically linguists, in order to be able to tackle its complexity, have divided language into different domains. For example, segmentation of words, or phonology, or learning word meaning, or morphology, syntax, semantics, pragmatics, and so on and so forth. Unfortunately, we won't have time to discuss all of these in this course, but we have selected a bunch of case studies which we will study in more detail in the follow-up lectures. So in each lecture, I will first go over what we know about that particular process, what are the most important experimental findings in that domain, and then we will look at some example models, how they're developed, how we can evaluate them, and what they tell us about that particular cognitive process. So stay tuned.